All right, everyone, how are we doing today? Doing good? All right, welcome to our week 5. So I had a quick question. So how's the lectures going? Good? Fun? Bad? Did you guys get your grades back for the exams? How was it? Oh, gosh. What was the definitions that were on there? What's an analog signal? What's a discrete signal? What's a bounded signal? What's an unbounded signal? What do you think exam 2 is going to be on? Guys want to give you answers? What's a linear time invariant system? That's it. You like that definition? Someone's going to forget it for sure. What is a linear system? What is a time invariant system? What's a system with memory, without memory? Is other definitions. You guys remember those ones? They might be on the exam. I'm just giving you guys that hint. Anyways, when's your guys' exam due? Or when's that happening?
Wednesday.
Wednesday next week? Yeah. All right, and then Joanna, you didn't move that date, right?
Yeah, I think we should.
Yeah, but you didn't do any changes, right? Okay, so I'll do that change later tonight. So that'll happen. As I said, they correlate together. So because everything we do in assignment 3 is correlated with exam 3, so that should be catching you guys up with that. So how is the actual homework handouts? Are you guys doing that? No? Come on, what's happening? You guys don't believe me? Let's see, that's why I think that's what I wanted to talk about. Are you guys aware of this homework? Yeah, so now it's on recording. Now everyone can do their homework, correct? No one's going to be like, I didn't hear about it. I didn't know what it was. All right? Read the book. Simple as that. Shalom's outlines, you got chapter 1, correct? Chapter 7, I think that's a state space equation. Chapter 2. Yeah, that's a lot of homework. Then there's a handout. Someone's asking, I didn't see no handout. I'm going to record that. Boom, there's your handout. No one's going to complain about that, right? Let's see. Consider a causal LTI system whose input X and that, boom, boom, boom. Verify that S may be considered a cascade connection of two causal TI systems. Draw a block diagram of this, draw a block diagram of that, draw a block diagram as a cascade of this followed by this. Oh, this is a good homework. This might be your exam. So I'll talk to you guys what I'm talking about. So you guys know from signal or system theory, right? You got 2 blocks. You got a feed forward, right? Feed forward block. And then you got a feedback path, right? And you can connect it if you have, assume this was X of, I don't know, let's just do X of N because I like N, right? The output, right? Let's just say it's going to be, I'm going to call it some C of N, right? Which is going to equal some transformation based off that of X of N, right? Does that make sense? Sweet. Then we have this feedback path that's also going to do the same kind of transformation. We're going to just call that one Y. Does that make sense? Now someone's probably asking, well, if I just block this right here, right, and I have an output and an input, right, I don't know what's in this box. I'm just, or my hand, I don't know what it is. What's stopping me from just doing the following? Feedback and feed forward. Right? Are these the same? Yeah, they should be the same. It's just that the way you implement it is going to be different when you do your block diagrams, especially on your codes, right? So I think I went over this, and that's how to do a transposed, or not transposed, direct form 1, direct form 2, and transpose direct form 2. big vocabulary. So, get some reading. 2. And the direct form 1 block diagram, all you're doing is you're implementing this. Y of n, I'm going to do this, is equal to, I'm just going to do some block. I think it's going to be b of I x n minus I, right? Is that correct? I think this is it. As, what's it called? As I is equal to 0 to I is equal to, I don't know, m, right? Does this make sense to everybody, right? Right? So if I have I is equal to 0, right? The first term is going to be b0 x of n, right? Does that make sense? And if I is equal to 1, it's going to be b1 x of n minus 1, right? Good? And it's a summation, so you're just adding all this plus, 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 right? So if I go down to I of m, right? Just going to get the b of m x of n minus m, right? Easy peasy. Cool. Minus. Now this is where people are like, this is where the wars start. Is it minus? Is it plus? Is the alpha minus? Is the... So I'll show you what's going on. From I, do I want to use I? Yeah, let's just use I. Doesn't matter. Actually, no, because this is the same equation. I'll just use J. There we go. Make them unique. All right? Of A of J, right? Y of N minus J, right? And you guys are going to understand this, right? So, what do you call it? It's going to be, for this, ignore the minus sign. It's going to be A0 Y of N, right? Is that good? And then A of 1 Y of N minus 1, right? Dot, dot, dot to A of N Y of N minus N. Is that understood? So the direct form is you're directly applying this. So the way that they want you to do it, the book wants you to do it, is assume this input right here. We're just going to directly implement this block diagram. So we're going to assume that this whole thing, I'm just going to use a different marker. Let's use this green color. This right here is going to equal to C of n, right? And then you got minus, use our black marker. A of j, y of n minus j. Actually, someone should have caught me there. This is why I did unique letters. This is actually one, y. We already have a y there. That right there is what we're trying to solve. It's our output. So if you think of this as like y of n is when, just think about it. J is equal to 0. Like this basically, this right here, if you think about it, kind of looks like this, except for this alpha term has kind of disappeared, right? This right here just gains our output. It's just a gain. We don't want that. Usually A is going to equal to, the first A of 0 is going to equal to 1, right? Just a wire. Make sense? So that's why it starts from 1, not 0, because that's already right here. Understood? Anyways. J, there we go. Or not, I just said it. 1. J is equal to n. Correct? So we want to directly implement this, and I'll show you this on the next page. Now help me out with this one. It's been a while. Or maybe this morning, I'll think about it. X of n, right? And I know I want to get to a node called C of n, right? So I'm just going to write that C of n right here, right? And I'm just preparing myself. To get to that, recall that there's a summation. This signal is going to be a summation of a bunch of x inputs. So one thing you should assume is that I'm going to try and get this node. All I'm going to do is just do this plus, boom, done, right? So that means, if I think about it, with no delay, be 0, right? Is that understood? If there's no delay in the system, you're just gonna get this part, right? No delay, it's a nice signal. What comes in comes out immediately, right? Boom, done. Direct form 1 of just a simple signal. You're done. And if you want it to go crazy, let's just do the following. Let me see. I'm gonna do this. I'm gonna put this plus right here because this is gonna eventually add with this to give you that y of n, right? So we want y of n. That's what we need to transform from this to that, right? So let's just draw this puppy right here. Y of n. You like that? So ideally if this was on the homework or a quiz or an exam, and he says, draw me, I don't know, what do you call it? A signal with no delay, and it just has this one gain. This is it. That's your block. This is technically a block diagram. Congratulations, you're done. Sounds good, but no, he's gonna make a pretty hard problem. So let me see. To directly implement this, we need to put a delay in here. All right. I'm gonna call this one D, right? So now we've delayed our signal. Is that understood right there? And now I need to put this through some kind of gain, B1, right? And now I just need to add this to that. Is that understood? And now, boom, you've created two. You have the original signal that goes right straight through it. And then you got this other signal that's just being delayed. It's stuck here and boom, just goes through there, right? You can keep going all the way down until you get to, let's see, delay, D, right? Dot, dot, dot. Until you get to x of n minus m, right? B of m, right? And then there's no plus sign here, but it goes up and all the way to here, right? Direct form, simple, right? And this is called the feed forward path. Just feeds right into it. All understood? All right, now someone's asking, how do I do the back path or the feedback path? Well, we need to delay our signal, right? Here's our output, right? We're delaying it by 1, right? Now we have y of n minus 1, right? It's delayed. Got to put some gain on it. Alpha of 1. I caught myself. So I want to talk about this because I think this is where a lot of problems start. I want to verify this. So you have this y of n, right? Correct? What is this equal to? It's equal to this right here. Actually, it's equal to this c of n, right? But I just said from our first example, right? There's this minus sign right here, correct? So there's another way to write this equation, and this is where all the signals and systems start appearing. Have you seen this? I equal to 0, I is equal to m of, oops, sorry, there we go, b of I, x of I, n psi, right? You've seen that, right? Equal to, I is equal to n, or not I, j is equal to 0, okay? Of a of j, y of n minus j is just this right here. That's your difference equation, correct? All we did to go from here to here is we popped out the y right there, and then everything else turned minus. All right? So this is where the war begins. It's where, like, there's too many teams. I'll tell you what's going on. One of the things that people will do is they'll make this a minus, or just put like a minus right here, or actually put a minus right here. So it's like a feedback. You have negative feedback. The worst thing you want in your filter or your feedback filter is a positive feedback loop, your circuit blows up. So sometimes, well, they always do this. They put a minus in there. I'll show you this if I did minus A of 2, correct? D, right? This is Y of n minus 2, correct? Right? And they put that minus in there so that when you go back into here, oh, it's equal to minus A1 y n minus 1, right? Minus A2 y n minus 2. Is that correct? This right here is your direct form 1 block diagram, where this part here is also equal to the feedback. Is that good? Anyways, let's see. That's page 3, page 4. Are we understanding how to do these block diagrams, right? Have you guys implemented this in code? No? Have you guys tried? No? Why? we didn't read the book. Yes, yes?
Did you go over some MATLAB stuff today as well?
Yes, yes, and that's actually what I'm going to do right now. So let's see if I were to do my homework and go over some book problems. Let's see. Because this is a secret that that's been passed down, but no one really wants to share it anymore. Is that the answers are in the book. Well, maybe that's not a secret anymore, but let's see. Where is that? No, that's state space block diagrams. I'll show you what I mean. I want to use a book problem from the book. Direct form 1 block diagram. There you go. What does this look like? See if I can zoom in. Can I zoom in? No, it's not letting me zoom in. There you go. It's on page 64 of 171, direct form 1 implementation. And it gives you the general equation of this. That's it, you're done. No one believes me? Let's copy this. Let's verify this. MATLAB. Oh, what the heck? Better yet, let's do something even funnier. There we go. Hello? There we go. Let's see. Let's start lecture 5. Oh, is that my music? No, it wasn't my music. All right. EE360, D, week 5. Actually, let's see. Doing homework problems. Let's see. Good old homework problems. Let me see. Do I have the file? Let me check. Whew. Lots of work here. Let's see, F25. No, that's 221. 360, F25, comp assignments. Yes. Implement this block diagram, right? And you got to do a direct form 1 block, a direct form 2 block, and a transpose direct form 2 block, correct? So I'm assuming everyone's confident with doing these, right? Should be easy, correct? And then how many delays and how many registers are in each one? Using a for loop or a while loop, that's great. Implement a program that implements each of the block diagrams that you drew in exercise 1. Indicate the number of delays. Calculate this. All right, this should be easy. Let's see. So, we got A1, A2. Oh, man, I don't want to type this. Let's do this. Okay. A0. Do I want to do that? Yeah, sure, whatever. I have a better idea. see if you can catch me what I'm doing. 1. This. Oh, I can hear the panics. Who's panicking on what I'm trying to do? It's matrices. There we go. Did I get everything? There we go. Hopefully I did. These are just numbers. They've been fine-tuned. I think Dr. Stuber designed these for you. Let's see. B of, oh, okay. You got a damping factor there. Hello. There we go. Boom. Copy. I tried making these as copyable as possible so y'all can get your job done. Let's see. Come on. There you go. Boom. Right? And now we want to implement these block diagrams. So I'm going to choose a time. So let's see, we got 1 delay, 2 delay, 3 delay. So my true time, I want to go from, let's see, we're going to have a delay of -3. I'm just doing that for my sanity check. To 51. Is that what he wants? First 51 outputs when the system input is, okay, yeah, so that's what it should be. For, let's see, I is equal to, because now we got to tell you about how to control this. Because if you throw this into your actual equation, it's not going to look good. Let me see. How do we want to type this into MATLAB? I'll show you. C of what? C of n is equal to, I'm going to do this, B of 1. B of 1 dot times, that's what I'm doing for sanity, x of, and that's what I want, plus, boom, boom. Let's see what I can do. Move that there. That's my first term. This is my second delay, and -1. Wait. Yeah, okay, let's do that. 3, third term, x -2. B, actually one more. There we go. And that's it. Fourth term, n -3. Boom. And then y of n is equal to, let's see, the actual input, C of n. That's what I was afraid of too. A1, wait, let me see. A1, 2, 3, 4. No, I don't like that. And I don't like this. 0 is equal to 1. A1 is equal to, there's got to be a better way to, wait a second, you can do this. There you go. Tell me if you caught what I'm trying to do. There you go. A2, I'm just doing this for to read it better. A3, that makes more sense. There you go. You like that? Okay. B of 0, that makes more sense. There you go. B of 1, boom, boom, copy. B of 2, 2, and B of 3. There we go. That makes my life a little better to read. semicolon, semicolon, boom, so it doesn't shout. And this one is our B0, that's our 0th delay. This is our first delay. This is our second delay. And this right here is our third delay. Good? This right here is our instantaneous signal, right? This right here is our first delay, right? Does that make sense? Dot times, because someone's asking me, why don't I just do this? Matrix multiplication is scary, and I don't like matrix multiplication, so I like scalar. I always try to do this. You can do this, it's fine, but sometimes I rather force it. If I know I'm doing matrix multiplication, I will, but I'm trying to do dot point by point. Does that make sense? So A1, because the last thing I want is, this is a 1 by 1 matrix, right? Multiplied by a 1 by n matrix, right? That means the output's going to be a 1 by n, right? I don't want that. I want 1 point. That's it. That's why I do the dot times for my sanity, right? Anyways, y of n minus 1, right? There's a delay. Plus? No, minus. There you go. Just copy this. Boom. No more thinking. Do. Boom. 3, 3. Is that good? And now we got to start figuring out how to play with this I, because this is your time. This is the real time we want, right? It makes sense, right? But the thing is, these are arrays. We got to translate this real time to an array time. So right now, I is our array play variable. I know I want to do something with n1, right? I want to do something with that first point, correct? But I need to bring this up so that this right here, because I'm going to do minus 3 n is, or what do you call it? Hold up, I did something wrong. It should be I. No one caught me. There we go. There we go. I. Does that make sense? So this is our variable I. It's going to be minus 3, right? This is going to be a minus 3, right? Boom, we failed. This one's going to be a minus 6, right? We also failed, right? X of minus 6, right, doesn't exist, correct? Because we want this one to be, what do you call it? We want this one to be like array index 0 or 1, right? So we need to make this equal to 1 by doing the following. Let's see if I can do this. N1 plus, because I got the delays. I don't want to do this without going too crazy. This is my value there. Let's see how the book does it for you. Start, stop. The start of the new vector. We'll figure that out. Actually, better yet, let's see what our input is supposed to be. X is going to equal... I've realized there's a cool trick you can do. N is equal to, greater than, or equal to 0. Is that correct? So why did I do this here? That's just Boolean logic. What is this?
It's going to be a set of integers up to infinity.
What?
I'm talking about that one.
This one?
Yes.
N is greater than 0, right?
Oh, it says equal to as well.
So, yeah, greater than or equal to 0, right?
So 0 to infinity.
Yeah, 0 to, well, here's our N, right?
Okay, 0 to until that one. Okay, I see.
F9. Look at this. Just ones. It's a unit step.
Interesting. I didn't know how to do that.
Yeah, apparently this is another way of doing it using Boolean algebra.
Oh, yeah.
Yeah, so that's how you can also do with the Kronecker delta as well. So you can just switch around and have some fun. So I want to throw this into this. But let's see, am I given anything else? Let me see. We're assuming that those are also zeros. So I'm going to do the following. Y is equal to zeros of size of x. Boom. Why did I do that? Because you see right here, 55 numbers, right? Let's calculate this, F9. 55 numbers, right?
Yes.
So now these should make sense. They're the same size, same arrays, correct? But now I got to figure out this problem right here. This is where I want to start doing some crazy calculations. How do I want to do this? Because this right here is technically our... I'm just going to call this delay. Delay is equal to -3. Because I know I have 3 delays in this circuit, correct? That's what I'm trying to plan. I'm trying to program this so that I'm using this delay. So if I have a delay in here, right, I'm going to absolute value that, right? That's my delay. It's going to be 3, right? But I need I to equal to, oh wait, I should have figured this out. How do you make this equal to 1? 4, or I is equal to 4, right? This right here, what's this going to equal? What? Oh, hold up. F9, boom, boom. 3, right? This is a 3, right? But we need to have a +1, correct? Got it. Now we have that. We have our start. Now our for loop can start going. How do we stop this? So we know that if we go out of bounds with this guy, let me just do this. End. Does that bother anyone? Right? No? Maybe? Actually, let me try this. Yeah, let's run this one. Figure 1, stem, what do you call it? X and Y. Yeah, let's see if this runs. Does not run. Why? Array indices must be positive integers or logical. Why did that happen? Oh. C of I. That makes sense, right? There's 4 in here. This should be 5. Okay. This right here is 1, 2, 3. And then this right here is 4. Okay. Let's look. Let's do some signal analysis. 1, 2, 3, 4, right? This right here goes over here, right? And then this goes here, right? This goes here, and then this is our unit step. It's going to be immediately going into this signal, right? This is where our 1 is, right? Our train's going to begin here, right? So why array indices must be positive integers or logical values? Oh, there we go. I forgot the I. Let's run that puppy. Woo! What happened here? That don't look good. Oh, it's because you got to do N. Wow, that looks pretty good. What do you think about that? Explain what's going on. Let me show you this. Has anyone here taken controls yet? No?
I've dabbled with it.
Unit step resonance. This is practical circuits. Have you ever guys played with the oscilloscopes and you see that little ring? If you don't probe your, what do you call it, oscilloscope probes correctly, you see a ring, it's an overshoot.
Yes.
The square wave just goes up and just starts ringing.
Yes.
That's this. Here's one, right? Better yet, if you want to be really fancy, do something funny. Do I want to know that? Hold on plot. This is gonna be bad. And what do you call it? I'm gonna do something funny. Watch this. Draw line. Draw my line is equal to 1's size of x. Yeah, let's do that. Let's see if this works. Draw my line. Yay! It worked! Alright, let's see. Line. Wait. Black. Or not black, that's blue. This is black. Line. Width. Let's make it 4. You like that? Does that look good? But why did it change color there? Something's wrong. N, Y, let's try it again. Whoa. Whoa. Whoa, something's going on, y'all.
Graphic card is overclocked.
Something's happening. I don't like that. You know what? I think it's this. Let's run it again. Run it again. Oh, it's the hold plot. Okay. Hold off. Okay, let's try that again. Boom, that works. Yay. Yeah, it's because I kept rewriting over that figure because it said hold on and it kept holding on, so that's why I was changing colors. Does that make sense? That right there is our 1, right? Does that look like a nice 1? Then I can do this. Line K, or actually dashed line K. Does that look good? And then you can say this is where you see that ringing, right? Does that make sense? Congratulations, you just did it. This is the best class in the world. Good? Now here's the problem. See this? The unit steps don't do that. We just lost 4 points. We need those 4 points. Where did those 4 points come from? Disk. Let's add that. Boom, we're done. Hooray, we brought it all back. You did program 1. That's it. This is your code. That's your answer. Actually, you know what? Answer. Like that? Actually, no, don't do that. There we go. Answer. Yeah, I'll put money signs too. Does that look good? Where did I get this answer? See, I told you I didn't come prepared. Maybe I did. Where did I get this answer from? See, it gave you a baseline of what to do, but this is just one way of doing that answer. But I just modified it so it's easy for me to see. Your code is your code. Design it the way you want to. You can literally just copy this and you're done with your homework. Or you can just do it the way I did. And then someone proved me wrong. Let's see. I don't like this. Boom. He changed the problem on you. Whoops. He changed the problem on you again. Whoops. How do you solve this problem? I just programmed it. It's good, right? We're done. Look at that. Ooh, what happened there? That's a pretty cool signal. Better yet, let me do some other fun things. Control Z, Control Z. Maybe I'll get rid of this. See if this still works. Ah, it's a gain coefficient. Okay, keep that out. Remove this one. Let's see what this does. Ooh, you see? More ringing. Like that? Now let's just say you did the following. Plus. There. That's going to be bad. Watch this. Oh, not that bad. Okay, that's pretty good. Minus. Plus. I want this to blow up. And it doesn't blow up at all. It's okay. I think he built a pretty stable filter. But that's your program 1. Now start throwing your answers. Here's your signal. Have fun. Good? Let's see. Next problem. So let's see. What's another thing? Actually, let's go over this. Built-in filter function. You guys know how to use the filter function? No? It's okay, because MATLAB will tell you.
First,
Help filter. And it tells you how to use the filter. Give your coefficients. That's actually why you... Did you guys notice what I was trying to do in the beginning? I was trying to do that funny like matrix. That was for this problem. So let's just do the following. A is equal to... Dang, do I have to do this? A0, A1, A2, A3. Is that it? Yeah, that's it. Man, so much typing. If only I did this as homework. B, B1, B2, B2. Is that good? Because the help function, when you type in help, the filter is asking for these coefficients, B, A, X, right? Your B is your coefficients, and it even gives you an answer there. It does a direct form 2 transpose. So all you do for this one is this. It's pretty simple. X is equal to, I don't know, set a new n. I'll call this one n is equal to 0 to, I don't know, 51 or 50. Yeah, 50. Y is equal to filter B, A, what's our x? X is going to equal our unit step, which is going to be n when it's greater than or equal to 0. True. Always true, correct? So let's see this output. Filter. Don't forget to do that. Not filter. Figure. I don't know, 2. Stem. N, that's our time, and our y. Boom. See, that works. Look at that. You like that? Let's compare it to this one. Let's see if you guys see anything. Actually, what's this value? 107, right? Or 1.1.07, right? What's this value right here? Are they the same? So technically what you guys are doing, this is actually a premium. It's in the signal processing toolbox. You either code your own or you just, pay to win. You can just use this filter and get your homework done in 1 second. Pretty easy, right? Literally, this is all you need. You're trying to build a program for this. You're building the filter program. So this one is more like you get to control and tune what you want to do. Does that make sense? So now let's see what else is there to do. Have you guys talked about state space equations?
not that I know.
So I think you guys are talking about that Wednesday, right?
Monday, maybe?
Or Monday, sorry. For the exam on Wednesday, right? This is very important. This is where you actually start needing to use the block diagrams. And you need to solve for your coefficients and program this. You can run an impulse function, step function. You need the toolbox for this one. Generate state equations for just the direct form 2 and transpose direct form 2 block diagrams. Why? Because you need memory. So let me just show you that before it doesn't jump scare anybody. And then actually, quick question before I move on to this. I have a question, y'all. If this exact problem was on the exam, can you do it?
No,
No?
not right now, not today.
Can you get the equations for y, c of n, and x of n right? No? Yes, maybe?
Yeah.
Here's a hint. It's in the book. Better yet, I was actually going to try and show you one of these problems. Let me see. Here's the exam problem right here. No one's watching. Hello? There you go. There's the exam. Considered a second order linear time or constant thing. All you got to do is you got to solve for your equations right here. There's your answers. See? Make sense? But state space equations, you need to solve for that one. So you can punch that into MATLAB. Let's do the following. Let me see if there's a good problem for you here. Actually, just for you guys to do your homework. Let me see. Generate state space. So you're going to use the same pictures that you got from here. Right here, you're going to use these same drawings, or maybe just copy it, use I don't know, like some printer or something. So you can start drawing your Q spaces. So I'm going to try and show you the following. See if I'm wrong. I'm going to do the following. X of n, and I'm going to do it canonically. B of 0, B of 1, B of 2, correct? And then we're going to go up the river. I think I should have drawn this a lot better. I like fuzzy. D, right? Plus right here, right? D, right? Plus. Boom. And then this right here is our y of n. And then we need to spider this back in. There we go. Minus a of 1. Minus a of 2. Is that correct? So state space equations are basically, hey, this is, what do you call it? What I'm trying to say. I'm trying to remember what he was talking about in class. Let's see. State space equations. Oh, that's in the back of the book. Let's see. Direct form 1, direct form 2. Oh, you're just solving for the next state. Okay. So I'm going to do the following. This right here, I'm going to call this one Q of 1. What do I want to call it? Yeah, whatever. Q of 1 n plus 1? No. Q of 1 is, I think I'm going to do it like this. Q of 1, and this one's going to be Q of 1 n plus 1. This node right here. So I have this state, Q of 1, right? It's just existing somewhere. I'm going to delay it. Boom, Q1, correct? I'm going to do the same thing right over here. Q of 2, n plus 1. Wait, yeah, Q of 2, n plus 1. And then this one's going to be Q of 2, n. Right? Does that make sense what I'm trying to do? Everyone follow me? I'm getting some looks. No, not following? Okay, so this is where you have this equation right here where you're going to have this thing called, actually this is the transposed direct form 2 block diagram, by the way, all right? Where you're going to have Q of n plus 1 is equal to a Q of n plus b of x of n, right? And then you're going to have another thing called y of n, which is going to equal c of q of n plus d of x of n. So I'm going to explain a little bit of what's going on right here. So difference equations use differences. They like running around. We like subtracting stuff. But in reality, we like seeing things chuck as like a clock. You know, back in CP 100, 200, when you start using a clock, you want to know the next state. You can predict the next state based on your current state and your input. Wait, current input, right? So based on what you know right now, you can predict the future. Does that make sense what I'm trying to say? Wouldn't that be nice? Like everything you have in your hands, like if I have, this is my current state, right? It's a black marker. And I have my current input, it's a blue marker. I know it. And then maybe it creates, I don't know, this dark blue marker in the future. Does that make sense? That's what we're trying to show you with state space equations. And the way you do it is you set it up like this. All right? And I'm actually getting this from the book, so verify that for me. So what I'm trying to say is, if this Q1 right here, actually, here's this Q1, right? Let me use this pink marker-ish. Q of 1 of n plus 1, right? Is that good? Is going to equal to this x of n, right? B1 x of n, right? And it's also going to be minus a1 y of n, right? Easy. This q of 2, right? q2 of n plus 1, right? Is going to equal to b2 x of n minus a1 y of n. Does that make sense what I'm trying to do? And then let me see. Should I rewrite this? Actually, I'll show you something else. What's y of n? It's going to be equal to q1 of n, right? Plus b0 x of n. Correct? To satisfy this, these equations need to be a function of current states and inputs. What is this right here? It's an output. We don't want that. What is this right here? It's also an output. We don't want that. We want current inputs and current states. So I'm going to do that on the next page 4. I'm going to rewrite this a little better. Q of 1 n plus 1 is equal to b of 1 x of n minus a1 y of n, right? And we just said that y of n from the last page was equal to q of 1 n, right? Plus b0 x of n, right? Current state, current input, right? So that means this is good. Plug and chug. B1 x of n, right? Minus a of 1, and then this is where it gets funny. Q of 1 n plus b of 0 x of n. Oof, I don't like that room. I'm going to do the following. See if you follow. See, minus a1 q of 1 n, right? And this right here is going to be our current input. Plus, okay, watch this. b of 1 minus a of 1 b of 0 x of n. This right here is q1 n plus 1. This is very important right here. So I wrote it like this because you'll see it in your book. This is a pattern that you can start following. If you do the next equation, which is this, I'll show you this. Q of 2 n plus 1 is equal to, what do you call it? B of 2 x of n minus a of 1 y of n, right? Right? If you start plugging and chugging this into here, right, you're going to get the following. b2 x of n minus a1, let's see, a1 q1n minus b0 x of n, right? This is going to equal, I'm going to put my current state, a1 q1 of n plus b2. Is this correct? This is supposed to be a 2, sorry. a2 b0 of x of n. And there you go. So one thing I want to start focusing on, everyone, is there's a pattern. Look at this number right here, and look at this number. They're the same, right? Look at this number right here, and look at that number right there. They're the same, right? And then you start realizing there's a pattern. Look at these two numbers right here. Look at these two numbers. They go up as this goes up too, right? There's a pattern. Study that. That's actually the more important part. Better yet, this is how you implement this in MATLAB, right? So if you have equation 1, right? Right? Equation 1, equation 2, right? And you can plug this into MATLAB. Easy. And then here's actually equation 3. Boom, I didn't tell you about this. And based on how we did it in our code, let me see if I can show you here. Problem, state space equation. Copy, paste, boom. And all you do is just type this. Y, actually no, I don't like this. Hold up. There we go. Y. I'm not sure if it's going to work, but let's see. Is going to equal to our Q1 minus A1 dot times Q1 of I plus, it's a problem, plus 1. There we go. B2 minus A2 dot times B0 dot times again X of I. There we go, right? But now you're like, hey, David, I don't get this. What's Q1? Let's see, I'll show you this. You can't solve for this because you need to do the following. Q1 of I plus 1 is equal to, mind if you spread it like this, minus A1, actually, let's cheat. Come on, I'm trying to get the answers. A1 Q1 of n, right? You notice that was the same, right? And this one right here, Q1, B1, A1, this is the gain, X of n, right? Done. Good? But now what's Q2? Copy, paste. Just change it to 2. And what's Q2? Q2 is, let me see, A1 Q1 minus B2 A2. There we go. And then, actually, hold up. Did I mess up my... No, I messed this one up. There we go. That looks better. Oh, why did I mess up there? Anyways, that's your answer. You're done. But now you got to start playing with this. Play with this. and then you can solve for your equation. Is there any questions about how do you do your homework? This right here is for a T direct form to block diagram. Answer question mark. Just put a question mark. And then all you got to do is just plot and you're done. Any questions? Easy to program. Hint, read the book. The answers are all in there. I literally pulled this one out from the book. All right, y'all. Have a good day.